Hello and welcome to Mercury Now, a vodcast series brought to you by Mercury Systems. I am your host, Ralph Gavares, and today's topic, the Military and Aerospace Electronics 2020 Innovators Award. Hello and welcome to the show. The recently announced Military and Aerospace Electronics Innovators Award has cast a light on the trusted and secure solutions Mercury Systems has been innovating to address the needs of the modern aerospace and defense industry. In addition to 2 Platinum Awards, Mercury received 2 Gold Awards and 2 Silver Awards as well. I'd like to focus today's conversation on 2 of Mercury's award-winning products, the Ensemble Series SCM6010, an Open VPX bulk storage module, and the Ensemble Series SFM6126, an Open VPX wideband PCIe switch. Both feature the latest in technology for high-performance embedded edge computing, or HPEC, a subject of great interest as artificial intelligence, autonomous vehicles, and electronic warfare, to name a few, are creating high demand for data center level computing capabilities in SWaP restricted and remote environments. My first guest today is John Bratton, Director of Product Marketing for Mercury Systems. John, good day and welcome to you.
Good morning, Ralph. Thank you.
Congratulations on the award, John. I think it's a great accomplishment. Now, the Mercury Awards were given for 2 Mercury HPEC system building blocks. What is it about these that is worthy of the title Military and Aerospace Electronics Innovators?
Yeah, thank you, Ralph. Great question. High-performance embedded edge computing, or HPEC, is giving a massive boost to the capabilities aerospace and defense system builders have to address their big process workloads remote from the data center. Our customers are seeing how commercially developed cloud-based AI processing is changing everything, from connected smart speakers and phones to backroom automation to autonomous flying taxis. And they need the same capability in their applications on their platforms, whether they are connected to the data center or not. By embedding cloud processing capability into their applications, our customers' platforms are gaining greater situational awareness and autonomy, and the ability to execute ever more sophisticated missions in an increasingly complex and competitive world. HPEC repackages the data center into aerospace and defense's de facto embedded processing architecture of Open VPX that they can deploy anywhere. We are very pleased to receive the Military and Aerospace Innovators Award. They recognize the importance of HPEC and what it is making possible. The awards are for 2 of our recently announced HPEC system building blocks, our Ensemble Series SFM6126 PCI switch, and our SCM6010 mass storage module.
Thank you, John. So what does HPEC deliver to aerospace and defense system designers? And how do the Ensemble Series SCM6010 and SFM6126 feature in that?
Yeah. Our customers want the same processing performance and capability found in the data center that they can embed in their mobile platforms. Think of the data center as being composed of scalable building blocks, specifically CPU server blades, powered by Intel Xeon processors with AI accelerators, GPU and FPGA co-processing engines, powered by such devices as NVIDIA's latest GPUs, again, which tend to feature on-die AI accelerators, low latency bulk storage to handle the memory demands of big processing tasks like AI, and wideband, low latency fabrics that efficiently connect everything together. HPEC systems are composed of the same functional building blocks. They just happen to be packaged in a form factor that aerospace and defense can deploy. Our Open VPX SCM6010 and SFM6126 are such building blocks. They mirror the data center's mass storage and PCI switches respectively. The HPEC approach is a logical, technological step towards smarter, sustainable on-platform processing. The challenge has always been how to take high-performance computing that resides in benign air-conditioned data centers and place it into size, weight, and power-constrained applications for deployment in the harshest, most contested places on Earth.
Thank you, John. At this time, I'd like to introduce my next guest, Sean McQuaid, Director of Product Management for Mercury Systems. Sean, hello and welcome to the show.
Hi there, Ralph. It's great to be here.
Now, Sean, it seems obvious. You take the best commercial technology that drives the most powerful data centers and place it where the data is, at the source. Why is it only possible now?
Well, think of it this way. Traditional embedded processing systems rely heavily currently upon a laptop kind of approach to system building. Mobile class laptop processors, which are already somewhat rugged and power efficient, are connected up to GPUs, storage, etc. with switches, as one might set up a home computer network. Now, the HPEC approach is fundamentally different. The HPEC base architecture is that of the data center. HPEC uses the same silicon, the same fabrics, same software and tools, and repackages them for deployment in aerospace and defense applications. To place uncompromised data center performance into swap-constrained platforms requires robust solutions to problems that address this industry's need for things like size, weight, and power performance, high reliability for dependable performance regardless of the conditions, and extreme environmental protection to deploy anywhere. Next, sustainability for long service life and sustained technology advantage, with the assurance of sustainable long-term technology roadmaps, so the underlying technology remains relevant over time. Next, system integrity, with built-in security that protects their systems wherever they go, and with trusted design, components, and systems built in trusted facilities. And finally, scalability and interoperability, by using commonality across interfaces for compatibility with other systems, and commonality across architectures for scalability and maximum technology reuse. The trick to basically placing the data center in the nose cone of a fighter jet to process streaming data from next-gen radar, for example, requires having robust solutions to all of these challenges.
Thank you, Sean. Now, John, if I had to summarize, aerospace and defense needs the data center tailored to their specific needs for use in their extremely challenging and contested environments. Would you say that's an accurate statement?
Yeah, I would, Ralph. That's exactly right. Aerospace and defense needs the processing might of the data center, whether they're connected to it or not, and they're doing this by taking it with them on their platforms. HPEC gives them that ability by protecting, shrinking, and making it secure. So think of HPEC as a miniaturized data center with uncompromised performance and scalability that is secure, extremely rugged to go anywhere.
Thank you, John. Now, Sean, I could see why repackaging the data center for on-platform aerospace and defense missions is a game changer. So I must ask, how is it done?
Well, it's through Mercury's industry-leading R&D investment profile. Our ongoing investments in focused R&D have produced the industry's most efficient cooling, packaging, and embedded security. We partner with industry leaders and invest extensively in world-class domestic design, manufacturing, test, and support facilities. Specifically, we have developed the technologies required to repackage the data center into a rugged OpenVPX form factor without making any compromises on performance or capabilities. We're able to shrink these systems and optimize them for power and cooling with processing board miniaturization and advanced air, liquid, or hybrid cooling technologies. We build in extreme environmental protection from the start with our MOTS Plus technologies that embed the most modern and powerful processors for reliable deployment anywhere. We sustain these systems and their performance with a wholly modular open systems architecture approach, or MOSA. That includes ANSI Vita OpenVPX compliance and also alignment with SOSA, or the Sensor Open System Architectures. And by partnering with industry leaders like Intel and NVIDIA from the commercial world, we develop next-gen products that are aligned to their roadmaps, and we share technology so that all data center processing features are mirrored within the HPEC environment with no performance or feature compromises. We make our customers' systems secure and trustworthy by building in the industry's most proven system security engineering with our built secure technologies right from the ground up. And we use our accredited DMEA facilities to design, make, test, and support these systems, and our trusted and managed supply chain to ensure device authenticity. And we build in interoperability and scalability. by using commonality across interfaces for scalability and interoperability, and with the same silicon, software, architecture, and the same fabric and tools from the cloud all the way to the tactical edge. It's the combination of all of these capabilities that make HPEC possible.
Thank you, Sean. So, John, HPEC is the data center made ready for deployment in aerospace and defense applications. Is that correct?
Yes, it is. HPEC exactly mirrors the data center. It uses the same processes, architecture, and fabrics, and the same software and tools run on it. HPEC systems are composed of ensemble series building blocks that mirror data center building blocks. We integrate them into our customers' purpose-built systems according to their mission needs. These processing systems run the same software, use the same tools as the data center, so our customers can leverage their existing applications with no porting required.
Thank you, John. This is quite an exciting time to be at Mercury. Is there anything you would like to add? What are some of the things that we have to look forward to?
It certainly is an exciting time to be at Mercury, and I would like to just touch upon one thing. We talked about scalability a lot, and this is certainly a cornerstone of the data center architecture, and we build that scalability into our HPEC solutions. At Mercury, however, we do a lot more than this. The technologies we use to ruggedize and make secure our HPEC systems, we apply to other form factors like rack mount and custom small and custom form factor. The ability to repackage the data center in other form factors is a huge advantage to our customers as they seek to scale their applications across domains and platforms by using a single enterprise architecture.
I'd like to take this opportunity to thank you both for joining me today. It has been a pleasure having you. Congratulations on all the awards winning products that we discussed today, and I wish you the best moving forward. Godspeed. I look forward to having you both on the show again today soon. Thank you. This has been another edition of Mercury Now, a vodcast series brought to you by Mercury Systems. I am your host, Ralph Gavares, signing off.